Thanks for inviting me. My name is Dmitrijs, as you already know, and today I will tell you how AI is capable of creating very realistic images. About me, I'm a machine learning consultant at Ford IT, and also I'm a founder of Riga Data Science Club. Feel free to attend our meetups as well. We have all about data science and machine learning. Before starting, I would like to tell a bit about my side projects that you might find interesting. One of them is Riga Real Estate. Is a machine learning based solution which can predict price of any property in Riga. You just should enter address, like address of this building. You enter floor, number of rooms, and it will provide price estimate. It is trained on publicly available data from advertisements. So the estimate is kind of maybe not so, a bit outdated, but it's still fun to play with. Other project I would like to tell about is Riga Faces. This is about mascaroons or Riga facade statues, and I have used neural networks to bring them to life. And this project aims to bring attention to the beauty of architecture around us, and we could imagine how these people could look in real life. Another nice project I was very interested about is historical photo colorization. So I was looking for historical Latvian photos and colorized them using neural networks. So as you see, I'm very passionate about machine learning in general and about image processing and all cool things. And today I would like to tell you how AI is capable of generating images like this, or like this, or like many other cool pictures you will see later in this presentation. And you will also learn by the end of this presentation how these three models work: DALL 2, EMERGN, and Stable Diffusion of Stability AI. Can I ask you to raise a hand who have heard anything of DALL 2? Oh, quite a lot. That's nice to hear. And I will still cover basics, and here is the agenda. So we will state a problem how AI could generate images and how different it is from image search we do in Google every day. We will next look at the building blocks of such a complex system, and we will take a look closer at image generation in general, how machine learning is used to generate images. We will also cover another building block about how AI relates images with text. Then we will bring this all together and look how this complex solution works. And we will conclude with different use cases of this technology, and also we will learn how it is already used and how it already changes the world around us. So let's start with the fact everyone loves images, and we are humans, we comprehend information visually, and this is the most effective information channel. And everyone loves kittens. So what do we usually do? We just go to Google and we write something. Cute kittens, okay, Google, please find me cute kittens. Okay, very nice. But how about some different query, like cat playing chess? Have you seen one? I guess no. Of course, some people take photos of cats occasionally sitting next to chessboard, and you could get some pictures, maybe some drawings. But still, it is image search, so you just enter text and you find an image. It is kind of text to image, but in a very simple way. You can't find something unique or something different that has been already put there by a human. What about this Google? Cat licking a cactus. Is it possible? I don't know. And for example, cat dressed as French Emperor Napoleon, holding a piece of cheese, very relaxed. I guess you have never seen before such pictures, but AI has become smart enough to generate such pictures. And we will learn today how this is possible. And before diving into the technical stuff, last example. Our goal is making AI to generate any text from any description, like this super crazy description. Cat looking as a prime minister of Prussia, wearing some Prussian clothes, eating lasagna. Yes, it's possible. And even this, an astronaut riding a horse in some photorealistic style, so it should be a photo, not a drawing like we've seen before. And DALL 2 gives us this. You don't want a photo, you want a pencil drawing, maybe you want an illustration for a book which is intended for children. Okay, let's ask it for a pencil drawing. Maybe you want to write a book about astronauts playing basketball with cats. You could even get this. So we are limited just by our imagination and by the words we could write and input to a model. So how does this work? Let's start simple. How does AI generate images? There are plenty of different solutions, and historically GANs have been the prominent one. GAN stands for Generative Adversarial Networks. I will not dive into details so much, but it has some limitations. It can generate photorealistic face like you see here on the left side. But in order to get this result, you should train explicitly on faces dataset. You could use GANs to generate cars, generate different sceneries, but it is usually limited to a single concept: face, car, or maybe animal. You can't generalize this model to make it generate anything. There have been attempts to improve this solution with variational autoencoders and also by combining both of these solutions using variational autoencoders GANs, which kind of take the best of both worlds, but they all have some drawbacks and limitations. And today's focus is a novel solution. You know, everything in machine learning happens very quickly, and we have novel solution like every month. If its presentation was in April, I would probably tell about GANs more, but today we will talk more about diffusion. And diffusion model is not an architecture, but rather an approach how to train your model using some concepts from thermodynamics. We will not dive into formulas because it's too complicated, but let's try to build an intuition, as we are short of time, how this works. Please take a look at this noise. Can you see something?
Rorschach test.
Yes, kind of. And I will gradually remove noise.
Something is visible, but not.
Let's see who
Dog maybe.
Who will be first to guess?
Looks like dog.
Has to be cat.
Yes, it's dog.
Dog. Spaniel.
Yeah, now it's dog.
Yes. So the idea is that we train network to gradually remove noise from a picture. This is a Gaussian noise, and by gradually removing a noise, we are getting some image. This is the forward process, and for human perception, it's hard to distinguish what is in on the picture if you start with a very noisy one. The same for machine learning model. You usually do not start with a very noisy image. But in order to make this work, we should do some training. And how training is done for such a solution? We start with a normal image. We add a little bit of noise, like here. It's a bit noisy. When we train neural network to predict the amount of noise and the position of noisy pixels for this particular image, after some time it understands how to remove it. Then we make image more noisy. Then we train network over and it starts to be impossible to remove even this amount of noise. So we continue on and on until network is able to generate image out of pure noise. That's kind of a general intuition how it works. But so as the final result, we have noise and we get image out of noise. And what happens next? We have to put some control how to generate noise in a predictable way. Like I want a dog, and this noise gets transformed to a dog, like here. But maybe I want a Napoleon-looking cat. How does this even possible?
Like Napoleon, yeah.
Yes. So next building block is the link between text and images. So how can we link these crazy textual descriptions with images? There's a solution called Clip. It is quite old one by the means of machine learning standards, and it connects texts and images in a very elegant way. So it is a machine learning network which is trained in batches where you get a batch of different images and batch of different image descriptions. You can take them from Google, from different stock photo storages. So all the data is actually publicly available on the internet. So a company who trained this network took a massive amount of annotated images and trained it this way. I hope it will show. So you have 3 different images and 3 different texts. You put this in such a grid and the model encodes them into some numbers. Then the model computes similarity, actually assigns similarity between each of the pairs. And the training objective of this model is to maximize similarity between matching pairs of image and description and minimize similarity between unmatching ones. So if you have a description about red apple, the similarity should get the lowest possible value for a picture of dog and highest possible value for a picture of cat. And what is good about this model, it can even compare relatively these descriptions. If you provide some general one, a photo of a bird, and some specific one, a photo of a bird sitting near a bird feeder, it will give highest score for more specific description. This way, the link between natural language and image is really strong, and we can understand many different concepts which are displayed on a picture. So we are done with this. So let's put these 2 blocks together and make this work. So we have a prompt, a kitten stock photo, white background. We pass it to a text encoder, which comes from the previous slide. It converts text to some numbers. Then we pass it to diffusion image generator, and this solution generates a cute kitten. But how we actually guide image generator to look at these numbers. One of the solutions is to use clip-guided generative networks, and one of the old solutions of the beginning of this year, which now is old already, is to guide EMERGN. So you pass text to clip encoder, and you try to generate images conditional of these clip embeddings. This was fun, but the results were not as good to show them for public. So this was mainly a playground for engineers, where we have generated some photos, but they are not good enough to be used somewhere else. One of the breakthroughs have been DALL, but not DALL I have been talking before, but DALL 1. It has used variational autoencoders and transformers and even GANs all together in different ways of this system. Another solution is DALL Mini, which has been working in quite similar way. We had some text, we encode it, but we have used BART encoder instead of clip, and this scheme has produced also some moderate results. And now let's take a closer look at the current state-of-the-art solution, DALL 2. The scheme stays almost the same, but there are some tweaks and some differences which make it perform so well. So we also have a text encoder. This is a model which converts text to numbers, and we have a generator. But in the middle we have this transformer model, which is also called a prior model. What it does, it maps textual tokens or textual numbers to image tokens. Let's imagine if you want to draw a house, for example, you start thinking how it looks like, what the roof will be, like you will place a window here, and here will be the sun shining on the background. And this process could be very similar to what happens here, but in the machine. So you have text encoding, which corresponds to high-level concepts of your intention to draw something, and image encoding is the actual position of the elements on a page, how the image exactly would look like, but expressed by numbers, as if you would write down, for example, on a page, like I would start drawing from X and Y position this to another one, but in a bit more complex way. And this part makes this model unique because it makes it produce very realistic samples, and instead of feeding text encoding directly to generator as was done previously, we have this diffusion-based prior model. And I want to emphasize that this is diffusion model, but it isn't diffusion as I have shown previously in terms of adding noise to pixels, but here we add noise to the encodings. And diffusion is sort of meta model. It's not some exact architecture like convolutional neural network. It's just an approach of adding noise to something and making the system learn how to denoise it. And the unit block of generator does the same thing. So there are actually two diffusion models inside, one in the middle and one in the generator. And one is transformer, and second one is convolutional neural network with residual connections unit. So there is another very popular solution, EMERGN, and the concept stays the same. We have a text, we encode it, and we pass encode into the image generator. But here, instead of clip, Google uses T5, which is actually a language model. It was trained knowing nothing about images. And it turns out it behaves pretty well on image generation task. And the reason for this is that it is a very large model. We have much more text available on the internet, much more text compared to publicly available images. And it is more efficient to use large language model instead of also large but smaller image model, which was trained explicitly for image generation task or image reasoning task. But this one is better, so it understands better the relationship between words. If you start typing in some very complex description, like I have shown previously, it understands how words relate one to each other and produces the encoding which makes generation result the best. So this is the reason behind the success of imaging. And on the generator part, we are using the same solution unit. And the most recent one, actually it was released just a few weeks ago, and it was even open sourced last week, Stable Diffusion. And this is a revolution, honestly. A revolution because it is open source and it is also very well performing. And it takes both of imaging approach. It uses text encoder from clip, even from clip, but text encoder, not image encoder. And it uses latent diffusion approach. What it means is that diffusion happens not in pixel space, but in the latent representation space. It means that before diffusing an image, we convert it into a latent representation and reorganize in this space and make model learn. Why this is so important? Because diffusion in general is a very computationally expensive process, and if we take DALL or EMERGN, probably you can run it in the data center, but you can't run it on your local GPU. But this one democratizes this approach in general, and you can run this solution in Google Collaboratory. You can run this on a modular GPU. You just need 10 gigabytes of RAM in order to infer from this model. And the inference process is also much lighter and faster. So by making this open source, Stability AI really opens doors for many innovations and many possible applications in this area. And I will show some later on. So yes, here are some links if you would like to check this out. This is publicly available. This Beta Gym Studio AI is a website you could generate any image, and you even have some controls of the generation process. And there is also Hugging Space demo where I have played around. So this is Elon Musk surfing on Mars. He looks lucky. I hope you do it one day. Let's try to draw a big picture. Of course, this might not be very accurate. These are just my findings, and some of these kind of not very well placed together. But in general, I see this image generation world as such. We have GANs, we have diffusion models, and we have transformer-based solutions. And previously we have used GANs together with clip guidance. So we used clip to encode and generative network to generate. It was kind of logical until diffusion has arrived. And diffusion uses the same clip guidance, that's why these two worlds overlap. But they perform much better. So we have DALL 2, Stable Diffusion, and EMERGN. And we also have some our solutions which are based on variational autoencoders and transformers, but these two are together because they kind of combine both of these technologies. And so we have arrived to this circle with green leaders, and it would be very interesting to see what's coming next. So let's wrap up how this magic works. We have text, we encode it into some numbers, or encoding or embedding, let's say. We run image generator, which could be either GAN, either variational autoencoder, either transformer, image transformer, for example, or either diffusion with something behind it like unit, and we get an image. And top 3 ideas, if you would ask me to name just top 3 things you should know about this, I believe we have all entered meta-modeling era where we do not have simple model anymore. We have a combination of different architectures mixed, each one playing own role, like we are having transformers somewhere in the middle, which is making these attention masks and making generation better. We have encoders which produce embeddings. We have convolutional networks which are guided by a diffusion training process. So this is really hard mix of many different technologies, many different models which are stacked together in a smart way in order to produce impressive results. What I also believe in is that qualitative text encoding is a crucial part of this process. If your model is like T5 or GPT, your text encoding understands a lot about text, about what did you want to say. It's kind of translating your words you type in into language would make this further process much better. And we also should remember that diffusion is not a model, but it is a solution how we train model, how we approach to training. And I have spent many time trying to figure out what is the architecture, what are the layers of diffusion. But then I realized it's not about having some specific layer, specific solution, but you could put anything inside. You have some constraints, and the only constraint I have found is that model input and output should be the same. So we could put transformer, which transforms this vector of 5 numbers into another vector of the same length. But you could also have a convolutional layer which does the same, but the main thing that you have the same output. That's why units are playing pretty well here, because you start with the same dimension that you will end with. So the most funny part since Napoleon image, how this will change the world. And in fact, it already does. This is recent Cosmopolitan magazine cover, and it is completely generated by DALL using this prompt. And I believe some more applications will come, like generating images for books, for posters, for magazines, anything like logos for these posters, and anything you could imagine. So any visual information could be generated using this tool. Also graphics design, you could make such cute game characters and you could experiment with. We also have some nice tools called inpainting, and you put a brush, you erase some parts of the image, and you ask model to inpaint in. So you could brush this clothes and ask model to draw some other ones. So really cool stuff. There is even this AA as a pair photo editor. You could write some prompt and get nice images. I will show how this works in real life, including in painting. So you write house on a hill. You put some style, which is Ghibli style. You inpaint something in the middle and you ask to detailize this part. So you erase and inpaint some other details. You also can control inpainting by guiding it with text. So that's how future work of graphic designers will look like. You no longer do any drawing, you're doing typing. So you put a dog, you would like to see it somewhere. Okay. It even transformed it into style matching the image. So I could look at this for a very long time. Here's final result. Okay, let's switch to next. There is even a Figma plugin. Does anyone of you use Figma?
Yeah.
So you want to design some new shoe for Adidas or for Puma. You ask it, okay, let's make it futuristic. Studio lighting, please. Voila, you have a new shoe.
And so how Nike does like this?
Yes, maybe they have this technology already.
You're taking job from designers, yeah?
Yeah. So the future is here. And you could do any other engineering, like you design new car, you design clothes, you design new furniture, you could do interior design. You can take, for example, an image of some interior and you would like to see how your sofa will look like. You just erase and inpaint it in and you get the result. So, what are the future trends? I believe prompt engineer sounds like a new profession. A person who is able to write such nice descriptions which produce results you want. You have seen, the more specific you are about the image, the better results you get. The illustrator, is it lost profession? It's an open question to all of us. I think no, because when Photoshop was invented, everyone was also thinking that it is the end for the artists and for all the creative people. But I think it's just a tool, it's just a new tool, and we should get used to it. And we should also understand how to use it most effective way. It also brings new opportunities for creativity to express yourself. You can start experimenting very quickly, and I think you can get more diverse results. I also believe that stock photos will be completely reimagined with this. You do not longer need to search for a stock photo, you just generate one. You just type the description of a picture you want and you get it.
How long to take to generate one portrait of person?
Stable diffusion inference on my laptop takes around 4 seconds.
And how big resolution is it?
It's by default it's around 700 pixels, but
700?
700
by long side?
height and width.
It's a box, but
It's half megapixel, yeah?
I don't know how to count it in megapixels.
one and a half.
But the good thing about stable diffusion is that because all the diffusion happens in latent space, we can generate arbitrary resolution images. That's why here we had, in this photo editor, we have width, height. So you just put any number where you want.
Yeah, no to it's
If you put some large number, it will take longer. Yes.
But quadratic complex.
So I think also image search will be much different. We will not search images, we will generate. It will be easier and just quicker. You will get the better result you want, and at the same time you will be sure that no one else had the same result. And even though you could enter same text with some other person, because of the nature of diffusion process, the results will be different every time. So it's stochastic. So I'm done with presentation. Thanks for your attention. And I will be happy to connect with anyone interested in this or any other cool projects we do at Forward IT. Let's work together and build a better future for all of us. Do we have questions now?
we already asked.
So there is this show last week tonight by John Oliver, and they just recently released the show about the AI generated images. And there was one thing, like they constructed a story, and there was thing that AI could not generate is John Oliver marrying a cabbage. It was always generating two people marrying and holding a cabbage. Can you maybe elaborate or speculate why do you think that happened, and maybe in which section was text encoder or learning set does not have such example, or why it could not generate it?
I think this might be a problem of text encoder, yes.
Yeah.
Because the attention mechanism, which is by nature the core part of every modern text encoder, which is transformer based, it maybe could have hard time to comprehend such relationship between cabbage.
Okay.
I also would like to comment a bit more about this. There is a special Excel spreadsheet. It is called Drawbench, and it is a collection of such complicated queries you should ask to such models in order to see how good they are at performance. And there are many fun queries. I recommend you to Google Drawbench. Your question?
Yeah. What would you think about the idea of the next Pixar monster corporation done with AI instead of 3D modeling?
I think Pixar will just buy these tools and will use it to generate characters or prototype faster.
I mean, what would you expect in terms of time frame? Would we see such a movie like in 5 years, 10 years? I've seen like videos on YouTube fully generated by artificial intelligence, but they were kind of abstract, so there were no kind of motion and cohesive story. So that's really interesting, because when there is a new imaging technology, then the next step would be to expect new video technology as well.
Yes, you're right. I think this is kind of a next milestone. We should have text-guided image generation, and I have already seen some papers on it. So there is an ongoing research into that direction. But for now, we have kind of image generation out of this because of the latent space all the textual encoding are residing at. We can interpolate between different textual encodings, which means we can gradually and slowly move from one description to another. For example, from a corgi dog to a cute kitten, and the image will gradually become less a dog and more of a kitten. And this way I have seen a very nice video about the creation of Earth. So one guy has made around 100 different prompts to DALL, and about creation of the earth, and he interpolated between them, and the result is available on YouTube, and it's really nice, really impressive. It shows some universe at the beginning, and it interpolates into some planets, then it interpolates into some oceans, then some creatures arise from the ocean and they start walking. There are dinosaurs, and all the steps of our history in between are encoded as different images, and we get sort of video because of this interpolation tool.
Sounds cool.
So maybe, is there already a discussion about the copyright? Like, who owns it? Is it the AI provider or the one who came up with the prompt, or what's going on in that space?
Yes, there are many different scandals related to this, and currently I'm not sure about DALL, but Stable Diffusion made everything so public, so you could use the results without mentioning anyone, even if you write like in the style of particular artist or of particular painting, you are not obliged to reference him. But I think it's just a sense of your personal attitude. If you write such a prompt, I think you should mention the prompt next to the image. Then it's so just clear. If you write this, no one should worry about. But there are many different things to consider, like generating violent images, as OpenAI, for example, bans this in this DALL and EMERGN, I guess will also ban this. But Stable Diffusion is completely open, so you can generate anything you could imagine.
It's possible to some porn also. Yeah?
Even such images and everything, and some monster creatures.
Interesting.
Yes. So everything you could imagine, and even something you couldn't imagine.
What could they imagine AI?
Yes. But people say you could not harm with images. You could not do harm. This is a question to doubt and to discuss.
That applies to regular images as well as the generated ones.
Yes.
Is it possible to take some sample and edit, and let's say I have this person, I would like to add some addition to this person. Is it possible?
Yes. That's why, for example, you could generate fakes. Like, I have seen this man doing something bad, or so there's also, with every new technology which is as powerful as this, there are some drawbacks to consider.
When you have this tool design some designs, like interior design or car design, eventually, as we see in designs, there are kind of trends or fashion styles that rotate every decade or so. Like, do you think in future AI would be able to kind of affect that, or it's still people will be guiding those styles in AI generated images?
Yes, it's a very interesting question, and I think some new styles will still be invented by people, but taking into account the long history of humankind and the amount of images the model is trained on, it can also combine many different styles. And here is the question about what we define as a style, because people also create new style by having some memory of what he has seen in his life. And the model works the same way. It just sees life through the training process and through the images we feed into it from the internet. So it just has own vision and own way to manipulate such concepts. So that's very theoretical discussion. We can't be sure.
I'm now thinking of cubist painting style, which is very much an idea of, okay, we make kind of cubes and we combine it with images, which is exactly the kind of thing that is being done by this kind of generation.
Yes.
You can take different sources, combine them.
Yes, for example, in this prompt
And
engineering-
nobody complained about the cubists being not original artists.
Yes, you could even write, for example, cat, comma, Qubit style, comma, René Magritte style, comma, Unreal Engine, and you will see something in between.
Yeah, I have a bit maybe more of a comment on the kind of creativity and copyright things. Like, no one is stopping people from drawing a picture similar to Picasso and then saying it's a Picasso. So it's still the same dilemma. Another thing is that these models, since they're based on real data, they're biased towards popular things. So you can have Elon Musk on surfing on Mars, but you can't have me on Mars, right? Because there's not enough images of monkeys in the internet, I hope. So it's not gonna dig into live data or something, but there are of course already advancements, and that goes to the discussion with the animations and things like that, where you essentially give it a small sketch or some more input data rather than generating from the noise, which will generate more precise results. And about the comment about the marriage of the cabbage, it's the same thing. If you could give it, okay, so cabbage should be around here and the person around here, you could generate it from that, but we will probably have to wait a couple of months for that model to be released.
Way too long.
Maybe 1 month, I don't know.
Sometimes it can imagine things I couldn't imagine. Like I've seen some people were asking Stephen Hawking doing parkour, and he did it. It's not funny, of course, but I mean.
But the imagination is in the prompt, it's not in the image.
Yes, and yes, sometimes it can't relate to concepts. And this drawbench shows really nice how maybe sometimes even simple prompts are not rendered correctly. Like if you ask to draw a green apple on a black suitcase, I guess it draws black apple. And I don't remember it exactly, but some very similar prompts sometimes are misinterpreted.
A problem of interpreter or inputter? Where is the main problem of this case?
I believe it in this text encoding, but I couldn't be 100% sure.
These things are hard to debug, yeah?
Yes.
There is some question again.
Yes.
I have a comment that, as I know, real person image generation on DALL 2 is blocked, so it is not allowed for ethical reasons. So you cannot actually generate an image of Elon Musk using DALL 2, and I think it should be blocked for all image generation software, because it really is unethical because of deep fakes.
That's your opinion.
How is manual fakes different?
Very
Like
easy.
someone adding existing face from Elon Musk Facebook to something disgusting. It's not changing the point, right? The realistic and the simplicity.
It's just
Yeah, I guess that's, accessibility and simplicity is the only difference.
I think
The difference in the
there is
scale.
no point to block it.
Yeah, exactly.
Reason is for not blocking is right now you have software which can deepfake basically video conferencing in real time. For example, they do example with Arnold Schwarzenegger, small Chinese girl. It's really different proportions of body. She did fake voice and looking and mimics of Arnold Schwarzenegger in real time. There was no editing, just video call.
Yeah, and it's both its face, its movement, its
Yeah.
voice, so it's everything. It's already possible. And back to that comment, I kind of agree with trying to block some things maybe out, but then at the same time, you will get an open source model like this, and it's going to be available anyway. So I don't think it's possible, and it's not possible in physical world as well. So
If you start blocking something, with
Yeah,
risk
yeah,
will be
it's-
growing.
it's internet.
possible
Once
the
it's there,
future,
you
just like
cannot
this.
remove it.
think the same thing as with Photoshop story, because Photoshop could also be used for deepfakes. And until Photoshop, creating deepfakes was much harder. The same thing here. It's just a new tool, and we should get used to it. But it's so groundbreaking that.
And I have one more comment that I remember. There are neural networks that are better at fake image detection than humans are, like orders of magnitude better. You can detect that image is being generated or faked or tampered with way better than human can. So the AI is an answer to AI as well.
So it's going to be the quest for authenticity, for authentication, anything in this century, like antivirus and viruses.
It's like hackers versus security people. It's the same battle.
But the future models would be better, generating even better effects that even those models can detect.
I suggest that this discussion thing we keep doing, just kind of let's officially finish the talk part and then continue this discussion. So those who want to run away can legally go. So thank you, Dmitry, very much.
Thank you for inviting me.